So here's problem 39 from the chapter 3 review. We're going to find the second derivative of y with respect to x for this equation. Let's start by taking the first derivative of both sides of this equation. So we get that. And so the derivative of x cubed is going to be 3x squared. The derivative of y cubed is going to be 3y squared dy dx. And the derivative with respect to x of 1 is going to be 0. How are we doing so far?
Good.
So far good. Okay. Now, what we like to do is we'd like to isolate the dy dx. And to do that, we're going to take the 3x squared onto the other side. And now let's divide both sides by 3y squared. And we get that dy dx is equal to negative x squared over y squared. And there's our intermediate stopping point. So far, so good.
Yeah.
Okay. So how are we going to get the second derivative of y with respect to x? Actually, I have that written incorrectly. There we go. The square is on the d. All right. Well, what we're going to do is we're going to start where we left off. Try that again. And we're going to take the derivative of that with respect to x again. And of course, whatever we do to one side of the equation, we need to do to the other side as well. So what do we take? What do we get when we take the derivative of the derivative of y with respect to x? That gets us our second derivative with respect to x. And what's going to go on over there? Well, we got a quotient rule. So let's go through the quotient rule mantra. It's bottom times the derivative of the top minus the top times the derivative of the bottom. Of course, we have a chain rule when we take the derivative of y squared. And then we've got the bottom squared. So far, so good?
Yeah.
Now what? Well, let's clean up a little bit. And we get 2xy squared minus 2x squared y dy dx, and that's all over y to the fourth. Now that is not an acceptable form for the final answer. This dy dx needs to be swapped out for what dy dx is equal to. So I'm going to get 2xy squared minus 2x squared y, and I'm going to replace the dy dx with negative x squared y squared. And this still remains all over y to the fourth. Now we can do a little bit of cleanup here. Let's cancel this y with that y there. So it goes down to y to the first power. And now what we end up having is that we have a fraction, a big fraction, but we have a fraction within a fraction. I don't like that arrangement, so I'm going to rewrite, and I'm going to say, let's pull this y to the fourth out, 1 over y to the fourth out, and now I've got a common denominator problem with the remaining stuff. My common denominator is going to be y, so I'm going to make both of these expressions over y. 2x, and instead of y squared, it's going to be y cubed over y. And then over on this side, I got two negative signs and turn into a positive. I've got a 2. I've got an x to the 4th between those two terms, and I've got an over y there. Pulling out the common ideas here, we got a 2 and a 2, pull that out. We got at least one x in both of those terms, and we'll pull that out. I've got a y in the bottom of the, combine that with the y to the 4th to get a y to the 5th. And then inside here, what's left over? A y cubed minus an x cubed. No, an x plus an x cubed. But, going back to our very original equation, x cubed plus y cubed, that's 1. So, my final answer is 2x over y to the 5th. And they say the answer is negative. So, did we drop a negative sign somewhere here? Oh. I did.
Yeah, it's minus 2
There was a negative sign right here, and we can just have that negative sign going through all the way through here. Negative, negative, and a negative. There we go. There. So I dropped the negative sign, but I was able to find it. All right, so there's 39.